3D printing your home and workshop on the moon, Mars, and beyond. I'm Tonya Hall, and joining me is Jason Ballard, CEO and co founder of Icon. Welcome, Jason.
Thanks. Happy to be here.
What does Icon do?
Icon is a construction technology company primarily working in like large construction scale 3D printers, but also material science and software to um, automate and digitize construction. 3D printers are like I said, our primary area of work. And so far, most of our work has been in housing, kind of tackling what's largely known as like the global housing crisis by trying to do construction faster with less waste, delivering higher performance buildings with more design freedom. And it's really been an exciting journey so far.
Tell us about your contract with the U.S. Air Force to expand 3D printing of livable and workable structures.
Yeah, so outside of our core work in residential, we also have relationship with the Department of Defense and the Marine Corps and the Air Force. And we had just finished up a phase of work in a SBIR, which is a small business innovation research grant. And we were moving on to a phase 2 grant, and NASA got involved with the efforts because NASA is very interested in this technology being adapted for use on the moon and eventually Mars. And so we just finalized that contract. And so we have just begun development of an off-world construction system that we call Olympus.
That's exciting. What are some of the challenges in 3D printing structures on other planets? How do you print in microgravity? Where do you get the raw materials? What powers the equipment?
This is a great question. So the moon is like an entirely different world. So there's almost like nothing that's not harder. In some ways, the Mars would be easier than the moon. The moon has hundreds of degrees in temperature swings between day and night. Day and night, so to speak, last 14 Earth days each. You're in hard vacuum. You're in hard radiation. It's not quite microgravity, but it is 1/6 gravity. And the dust that you have to work with and exist in is like incredibly abrasive, incredibly aggressive. It sticks to everything. It's electrostatically charged. It might cause electrical arcing. And so it's just a very difficult and challenging environment. It's an entirely different world. And so we're trying to develop a system that can work in hard vacuum, that can work with like reduced power availability that we anticipate we would have as part of working on the moon. And then we have to actually, like most technologies for the lunar surface are designed to like avoid the dust or mitigate the dust. We actually have to handle moon dust, or what's known as lunar regolith, because that's going to be our primary feedstock for building material. Because if we have to haul all of our own material up to the lunar surface, we are never going to get a moon base. We ran the numbers on the dry material of one of the houses we printed here in Austin, Texas. And to get just the dry material up to the lunar surface would be about $1.4 billion. And with that price tag, we're never going to have a moon base. So we're going to have to learn to live off the land and to use the resources of the moon to exist on the moon. And our early research so far suggests that not only is this possible, but it's like very, very exciting. I can't believe I get to work on building humanity's first home on another world.
I am so jealous, Jason.
No, it's great. Where else can you like work on the global housing crisis and build the moon base? No, only at Icon.
Oh my God, exactly. So how do you go about testing your equipment and processes for the moon or Mars here on Earth?
Yeah, so NASA has a pretty well-developed technology development cycle where they use things called technology readiness levels, or TRLs. And so we're following sort of their systems engineering process. So in the early days, we're doing like a lot of design concepting and getting our functional requirements based on what we know about the lunar surface. We're now in a really robust design phase and benchtop testing phase. So if you came to our lab, we're testing lasers and microwaves and infrared because we can't use water-based concrete on the moon because water sublimates. It turns straight to a gas. We're gonna have to find a way of like making a building material without using concrete, but still using an additive construction approach. And so we're doing all that benchtop testing. All that information will feed into a full-scale prototype that we'll be developing in the next 12 months. And then from there, we'll begin vacuum chamber testing, cryogenic testing, et cetera, to continue to mature the technology, make sure it's ready to be on the moon this decade.
How might the lessons learned from this space effort help us build better structures back here on Earth?
I'm actually so glad you asked that question. A lot of people are like, wait a minute, are you guys confused? You're like, you're tackling homelessness over here. You're building like middle market houses over here. And in the moon base, like what's going on? And for us, these are like, they feel like the same effort. It is so clear that what we need in construction is a paradigm shift. The future of construction is digital and automated. And it just may be that space age technologies are what is going to help us solve our problems in construction here on Earth, right? So that the answers to our problems on Earth just may be on the moon. And we think that's exactly what's going to happen, that this will actually accelerate and catalyze a lot of the breakthroughs in these paradigm shifts that we think need to happen for the good of all humanity.
I love it. So what should we look for next related to construction on the moon?
So what you should look for next, I'm sure somewhere in the middle of the decade, they'll want to do like surface demonstrations. And so I think we'll fly some version of our hardware up to the lunar surface to continue to mature it and give it a very thorough test before we fly up the full maturity, full scale system to begin construction of lunar infrastructure to make humanity's first home on another world.
Now, you have something on the wall behind you. Is that an example of what that might look like?
That's exactly right. So we worked with two different architecture partners, BIG, the Bjarke Ingels Group, and Search, to actually go through a very thorough master planning exercise of what is it going to take to build them. And there's going to be launch and landing pads first, and then roads, and then habitats. And we wanted to use those actual designs to inform what we were engineering as a construction system, because nothing would be a bigger bummer than to spend a decade building a construction system only to find out it was like 3 feet too short or 2 feet too narrow or something like that. So we really wanted like the most realistic concepts we could develop, and NASA didn't have any of these on hand, so we had to do that work ourselves.
Jason Ballard, CEO and co-founder of Icon. If somebody wants to connect with you, Jason, what's the best way they can do that?
Great. Yeah, if you want to find out more about Icon generally, iconbuild.com is a great resource, has all of our projects, what we're doing, job openings, et cetera, et cetera. And me personally, I'm on Twitter at Jason D. Ballard.
Sounds good. Thanks again, Jason.
Thank you.
And find more of my interviews right here or at tonyahall.net. Thanks for watching.